Okay, it's just a quick look at some of the theoretical development of the equation of a conic, which in this case we'll look at the ellipse. And the development of it's the same for the hyperbola as well. But I'm just going to look at the ellipse case right now. So the ellipse was centre 0, 0. And I'm going to look at developing the equation. Before I do that, I'm going to start with what we call the focus directrix definition that we've talked about in class. The fact that PS to PM as a ratio is E, where E is called the eccentricity. It's a constant. Now, given that that occurs for every point on the ellipse, that means that AS to AN, AS to AN must also equal E, because A is a point on the ellipse. So that is that AS is equal to E times AN. Similarly, the same thing must happen from this point B as well. So also B being a point on the ellipse, so BS must be equal to E times BN. Alright. So if I then look at those two statements, and I'll call that one 1 and I'll call that one statement 2, and if I then add them together, we go 1 plus 2, then what I get is I get AS plus BS is equal to E lots of AN plus BN. If we come back up here, and if I've added AS and I've added the BS on, then what I've got is 2 times this distance. So I've got 2 lots of OA is equal to E lots of, now AN plus BN is 2 lots of ON. I've got AN and I've got BN, so I've got 2 lots of ON. So I've got 2 OA is equal to E lots of, I'll actually put the 2 out there, 2 EON, 2 lots of ON. Alright, and then if I subtract them, 2 minus 1, I get from my statements, I get that BS minus AS is equal to E lots of BN minus AN. And again, looking at what that means, I go BS take away AS, then that's 2 lots of this distance in here, OS, 2 lots of OS. So that's 2 OS is equal to, and if I take BN and take away AN, then I'm just getting this AB, which is again 2 lots of OA. So I'll write that as AB for now, the AB. Alright. So then what I'll do is using these two equations then. So 2 lots of OA is 2EON, and 2 lots of OS is equal to AB. So just go over them again, make sure you get how they came about. And then let OA equal little a. So this distance here I'm going to call little a. So that would be the point A0. Okay. If that's a point A0, then from my equation 3, I get 2A is equal to 2E times ON. And from that I can gather that ON is equal to dividing by 2E, A on E. So ON is A on E. So this distance here from O to N is A on E. So that means that this point here is AE0. That gives me straight away the equation of this directrix must be that X is equal to A on E. So I've now managed to work out what the equation of the directrix is. Taking this one here, equation 4. From 4, remember AB. I've left the E off here, that's why I wasn't, sorry. So EAB I've got here. Now remember AB is 2OA. So it's 2A there. So I've got 2OS is equal to 2EOA. That's from 4, which means I get 2OS is equal to 2AE. OA, remember we said was A, little a. And so in other words, OS is equal to AE. So that gives me this point here. OS is AE, so S is AE comma 0. So what I've got out of this is that if I call this point A, then I've got the equation of the directrix is A over E, and I've got the focus, S, is going to be AE 0. Now, the ellipse has a nice little symmetrical property. So whatever's happening on this side, the same thing's happening on the other side. So if I've got one equation, sorry, that should have been x equals A over E. If I've got one directrix over here, I'm going to have another directrix over here. So I'm going to have the directrices as plus or minus A over E. If I've got a focus here, I'm going to have another focus here, what I'll call S dash, and S dash will be negative AE 0. So there's a couple of important points about the ellipses equation that we need to know. Okay, so let's see if we can use them to find the equation of the ellipse. So we know that PS over PM is this constant E. So in other words, PS is equal to E times PM. So what I'm going to do is I'm going to use this as a locus definition using my new information about what the focus is and what the directrix is and substituting into here. Now when I'm doing locus questions that involve the distance formula, then what I want to do is I want to get rid of that square root as quickly as I can. So I'm actually going to use this as PS squared is equal to E squared PM squared. And so the distance PS will be the distance from the point PXY back to the focus AE0. So at PS I'm going to get X minus AE all squared plus Y minus 0 all squared. So that's using my distance formula but squaring it to get rid of the square root. Is equal to E squared. Now M lies on the line x equals A on E. So its x coordinate is A on E. It's a horizontal line, so I can just subtract the x coordinates to get PM's distance. So in other words, that's going to be A on E minus x all squared. Okay, so I'll expand that out. So I'm expanding it out, and then I'll just quickly run through the algebra, simplifying as much as I can. Okay, so that's just bringing everything, all the x squareds to the one side, and bringing all and the y squareds, and then bringing the other pronumerals over here. So what I'm getting here is I'm getting x squared outside of 1 minus e squared plus y squared is equal to a squared outside of 1 minus e squared. Alright, so what I can do now is divide by a squared 1 minus e squared, and that gives me x squared on a squared plus y squared over a squared 1 minus e squared is equal to 1. And so what I've got there is a nice little equation of an ellipse, centre 0, 0. Now at this point here, what I can do is to make this a little bit simpler, I can let b squared equals a squared 1 minus e squared, and so therefore I get x squared over a squared plus y squared over b squared equals 1. Okay, so now we have a nice little equation of an ellipse here, and this is important because it tells us what the b squared stands for, and it also links our a and our e together as well in a nice little formula. So we'll come back and use that formula. So this is the equation of an ellipse. This is the general form of an equation of an ellipse. Centre 0, 0. X squared on a squared plus y squared on b squared equals 1. It should look similar to a circle equation to you. X squared plus y squared equals r squared. And in fact, as b approaches a, then what you're going to have is you're going to get that E is going to approach 0. So if you have a look here, as B gets closer to A, then E must be getting closer to 0 to make that come true. And so what's happening then is that the directrices, remember the directrices, their x is equal to plus or minus A on E, and because E is approaching to 0, then they're getting further and further apart. And then the foci, which is, remember, plus or minus AE 0, well, that's heading towards 0, 0, because E is getting closer to 0. So the foci are going back towards the origin. And that's what gives us then, is B approaches A, then what's happening is we're approaching a circle, x squared plus y squared equals A squared. And this is called the auxiliary circle for the ellipse. Okay, so a little bit of information there that we'll come back to later, but it's just important knowledge at this point. The important thing, really important thing here, is that we've established 4 things. We've established a general form of the equation of the ellipse, x squared on a squared plus y squared on b squared equals 1. We've established that there's this relationship between b, a and e. B squared is a squared, 1 minus e squared. We've established that a, being this point here, 0, 0, gives me 2 other things. Sorry, a0, a is a0. Then the focus is ae comma 0. And the directrix is the line x equals a over e. So the equation of the directrices, the location of the two focus, the link between B, A and E, and the equation of the ellipse. 4 important things there.